Hello, everyone, and thank you for joining us to this wonderful evening. I'm here with Perry Shalom, who's going to talk to us a little bit about bridging. Perry, as you know, but my viewers might not know this, you're a very good friend of mine and an amazing colleague who basically taught me Flutter over her plate of hummus, which was awesome.
Right.
And so tell me a little bit what we're going to talk about today.
Okay, Dor. But if you presented me, I should present you as well. Dor Summit, a wizard of Kotlin, which the past 2 years, I think, 1 year, 2 years, also
Something like that.
been exposed to Flutter. Yeah, and then we started as a Flutter and hummus, discussed about it, about the ideas and stuff, and that's what brought us together. So yeah, we lately came with an idea, right? Um, about another thing we can teach everyone that would like to know how to make a simple bridging between the Flutter layer and the native layer that runs the Flutter. Um, so we
Why is
can,
this an issue?
I will try to keep it short, my answer. But on my opinion, if you're a native developer, sometimes you find it more easy to develop some low layer stuff, low layer code on your native with your native development skills. So maybe if you want to develop it on Android and on iOS, you can use this bridge just to call it from Flutter and then get the result from the native. Actually, I have an example. Lately, I made a nice app that uses heat camera. Heat camera? Did I say it right? A
The
camera that
for the hit scan to see where the
yeah,
user looks.
exactly, but um, more like it shows the image with the temperature, like a heat
Oh,
map. Yeah, uh,
awesome.
yeah, which is a nice side project that I'm doing. Um, so the native camera cannot show you the temperature through its lens, right? Through like every device. So what we did is we used a FlareFX camera and plugged it to the device, which is could be Android and it could be iOS. But unfortunately, we don't have a plugin, especially from FlareFX, that supports Flutter. So in this case, I had to use this bridge with uh, Flutter calls it a method channel. I had to use this method channel to get results of the image and also to produce the images and to produce the preview from this camera. So this could be a great example when you
Cool.
want to develop stuff that they don't have a plugin.
So Flutter is a as a rendering engine. It has a lot of awesome solutions for rendering, but as it is being hosted at the end of the day on a native application or a web component now, or on TVs even, it sometimes
Right.
needs to communicate with the system to do stuff.
Exactly.
So if I understand correctly, just like in your example in the camera, sometimes you just literally need the communication with the system to get what you want. For example, the images or the stream of images or whatever.
Exactly. Whatever. Yeah, exactly. Whatever the your
Cool.
apps needs. Yeah. In most cases, I think you don't need to use this kind of solution, but I find it very helpful for me. Kind of a native developer, which could be iOS or Android, and now I'm using basically I'm trying to use um, as much as I can. I try to use Flutter, but sometimes for my solutions, I have to use this solution. By the way, many plugins that we use today are already use this method channel, but they have their own method channel of their own. Yeah. Um,
Cool. So before we
yeah.
get ahead of ourselves, let's talk about what we're going to do today and what we're going to build and which tools we're going to be using to tackle this problem.
Okay. Yeah. Cool. So we try to find a simple problem and to present a simple solution. Of course, you can find many other problems and solutions, but we wanted to keep it short. So there is so many things we want to show you today. So the problem we talked about from the Flutter side to the native side, we chose to show how to save secured data locally on the device. On iOS, we can use the keychain. On Android, we can use the, how does it call? Encrypted shared preferences, which is available from Android 21 and above. So that's one from the Flutter side to the native, and then it gets the results. It simply uses the native solution. And there's another problem we thought about. For example, you told me recently that you also used this kind of solution. We want to know whenever the Flutter screen is presented, but we wanted to call it from like on our events, something like a customized events that we wanted to know. So in iOS, we did it with the native callback for the system, and then we called Flutter and said, "Hey, Flutter, this is native. You are being presented." Some kind of this message, and Android also. We did it on the resume. We said to Flutter also, which is being presented. So what the cool thing here is that the method channel is communicating in both sides in a bi-directional way. Yeah,
it's very cool. So that it's a sort of one-way solution that the Flutter framework and the Dart kind of engine can communicate with its hosting, whatever, right? So
right. The embedding.
At the end of the day, you do need to know the native framework, but the Flutter side, which is the app side, which is the pretty side, does know how to use the data that it receives or the events it receives, which is kind of cool.
Yeah, I find it very cool and useful. So
right,
let's dive in.
Walk us through it. What are we saying?
Yeah, what we're going to do here today is not live coding, and not we want to do something like the boring show. It's not going to be a boring show. It's going to be a code review show or something like that. It's going to be a code review. I didn't open a pull request for that. We can do it later. We're gonna simply go over the code in this video.
I won't be commenting live though. I'll be commenting on my voice, not on the code itself.
Yeah, exactly. And by the way, yeah, we're going to publish this code. So and attach it to this video. So yeah, we thought about let's use the iOS to show it. Oh, it's already running. So it's here. A super simple app, a Flutter app that has only two inputs, key and value, which we can save and load. So let's dive into this Flutter code. I use the stateful builder, which is a nice thing I recently discovered. Just because I wanted to keep it stateless, my homepage will be stateless. So the only thing I would like to regenerate is kind of this, only this part, and that's it. Without the buttons, without the title, I wouldn't like to render the whole tree. So that's why I used this stateful builder. So what we have here, we can use this inspector maybe. Not sure if it will work, but let's try it. Now, oh yeah, it is. There we go.
Amazing.
Yeah, that's our stateful
So this
builder.
this is one of those tools that you can just use, and it points you to the right widget to look at. That's really cool.
Right. Yeah, I use it a lot. Plus, it also jump into the code wherever I click.
Oh, that's awesome.
One. Yeah.
I never noticed that. That's cool.
Yeah, very useful. So yeah, actually, I'm regenerating the same buttons, which yeah, I can note to self to fix it later.
Tisk.
Yeah, the only thing I would like to regenerate the UI of it is actually this column, and that's it. Oh wait, these two text fields. Cool. So we have two buttons. Let's see what they do, and then we can dive in. So we started with iOS. Let's see what we did. But this
looking at the
example
code,
is
So looking at the code, I see that you're using the text fields, and the text fields have controllers because we need to draw the information out of them.
right.
And then if I'm looking at line 57, you're actually calling a static native bridge and saying save to secure data, where the key is the controllers or the key controllers text, and the value is the value controllers text. What is this native bridge? What does it do?
Okay, cool. I called it native bridge just because I find it more self-explanatory name. You can call it a method channel bridge, method channel manager, whatever. It has only simply a service class, which has the platform of the method channel. Here, whatever the string you will choose here, you must use the same string on the other side, on the native side. So if I'll go back to native bridge,
this is the method channel. All of this amazing stuff that we talked about all boils down to this, little object called the method channel.
Yeah, that's right, exactly. This one.
Okay. So how is it defined?
Native bridge is actually a wrapper of the method channel. How it is what? Come again?
How is it defined? The method channel.
I can explain how I'm using it, but if we want to dive into the method channel, this is how it looks like.
Oh no, I didn't mean to dive in like that. I meant to like
okay.
What's the string that you pass to it?
okay. That's the name of the method channel. It should be a unique name because, as I mentioned before, all other plugins also use their own method channel. So you wouldn't like to override this or mess with it. So you should choose your own channel. Plus, you don't want others to mess with your method channel. So this is what this string stands for. It's gonna simply connect to your other side method channel on the native side. We have other. Actually, I didn't never used it. The other default values you see there, the optional arguments, right?
The codecs and the binary messenger. Yep.
Right, exactly. I never use it. So let's see how am I using this platform object. Oh, this is not. It shouldn't be so hard to find. Okay. There's the handler. Here I set simply a function that deals with the method channel. I'm sorry, method call handler. And these two are simply the invocations where Flutter wants to say. Let's put it this way. Here I'm using about whatever the native calls to Flutter, and here I'm invoking the messages from Flutter to the native. Okay.
So as we previously said, the method channel can go both ways. It can also exactly. Listen to events and can also send out events.
Right.
Those methods are exact method names are as they will be called in the native code, or is it going to be something a little different? Actually, let's dive on that later.
Okay. Yeah, we will.
Yeah.
Here I put
because it doesn't matter because it's just native implementation.
Yeah, that's right. It's also on the native side. I should also use the same strings as well, which we're gonna see pretty soon. Okay.
And I see the argument. The argument is a dynamic object. That means it can be a bunch of different things. It can be a string. It can be probably like primitives.
Exactly. As long as it's can be decoded inside this bridge, that's why it uses codec as we saw before. As long as it can code it and decode it, So we that's this class should be. I hope I explained myself well.
Arguments are things that can be relatively easily serialized or deserialized. So things like
Exactly.
strings, objects, maps,
Right.
or easily translatable objects. I mean, lists of primitives. And this is what we mean by objects, by arguments, at least by the
Arguments.
dynamic arguments. Obviously, if you wanted to do other fancy things, that's when we needed to turn to our friends, the codecs. This is not covered in this talk.
Right. Good. So here is we saw how Flutter calls the native, and let's see how the native calls Flutter. And that's an example for this implementation. You can ignore these values. Just yeah, you can have like infinite ways to implement stuff. So what I did here is I used a static private, static setter, okay, where I put here the logic in the setter, so we can ignore the logic inside of it because it's boring. What we're gonna see here is how did I handle the incoming message from the native to Flutter. So what I did here is simply did a switch on the method. The method is simply a string. So yeah, I did a switch on a variable string, a string variable. Well, you mentioned about the strings, which they need to be the same as the native. So that's exactly what happens here. When Flutter gets the message, it has to be the same string as the native sends. Okay, cool.
And then just like a regular function, it has a result, and then it returns that result.
Right.
And we're wrapping it as a future because it needs to be, because everything is asynchronous.
Yeah, and it should return a future, because if I will do this, well, it also works. The method should return a future, so that's why I did it. But I guess it wraps itself inside a future anyway.
It is a future handler. It is an asynchronous call at the end of the day, but I mean, you can also make the call itself asynchronous and do all your fancy calculation inside of it, like calling backend, calling calling other native stuff.
Mm-hmm. Right. Plus, this result will be transferred back to the native. Whenever a native sends stuff to the Flutter side, the native has also a callback. So the native will get the result that I'm putting here. That's why I returned this result. Yeah.
And it's just like an API contract that you know what's coming back and forth at the same time.
Cool. Exactly. Yeah, that's exactly what I wanted to say. It's like a protocol. You need to have your own protocol. I chose to use this kind of protocol when I use only success and failure. It could be anything. Okay, as you can see here, the future is of dynamic. So yeah, you can use anything here. Yeah, in my implementation, I chose to do that, which the success is a string of 1, the failure is a string of 0, which the iOS and the Android side are expecting to get these values, 0 or 1.
Cool.
Okay, so after we saw this one, I think we can dive into the Flutter, to the native side, right?
I think so. So let's wrap up a little bit and see, maybe let's see it in action before we dive into the native stuff.
Okay.
So when we're saving a key and value pairs, what we're doing is we're invoking a native method. The invoke native method actually has a pair that's coming in, right? That's the arguments that's coming in, the key and the value. And what's going to happen is we're going to be calling
this one.
So it's coming in. It's coming in with an object of a key and value. And what's going to happen is that if we jump back into the invoke native method, we'll jump back in, and then we'll see that will be calling the platform invoke method with the object of string spring. And then we'll be getting a result from the native code on which we will be returning it and doing some stuff with it, setting the state, refreshing the state and whatever.
Right, actually,
Cool.
yes, yeah. Let's zoom out a bit. Yeah, we started from here anyway, so yeah, we can dive in from here. Exactly what you explained. Save to secure data is this one. Yeah, actually, I don't need to repeat that.
Save to secure data has the thing. It does the stuff, and you all get it. No, but if we actually save a thing, save to secure data, we do what we're expecting to do. We're saving the key and the value. Load does the exact opposite. Given a key, we'll be given another value, on which whatever happens will be setting the new state to come in, where the state of the view will be set to the value controller, or on the load, but on the save it does the same thing. It just sets the state.
Yeah, we can change.
Or rather, it doesn't need to, because we already have everything filled out already, so it doesn't need to. All of that async await stuff is just fancy us doing fancy things. But yeah, it just means don't move on to the next line until I'm done. I think at this point, I'd like to see a flow of this to see, just to see the thing run.
Okay.
And then, yeah.
So I just run it on iOS, and then we will run it on Android. What do we want to save? Like hello. Let's see. This is the key, right? So this is a secured key. Okay, that's a long key.
That's a very long key.
Yeah, here is a secured value. Okay, and if I will click on load, it will try to load something from here. It will load nothing. So let's load this nothing. There's the result. I'm also debugging this one. And I got only the default value, because the result itself, and just return the itself. This is a secured value. Oh yeah, on my implementation, if I'm sending here a value, it will be the default value. So whenever I don't have an actual value, I will get the default. So yeah, I have to delete it and then load. Okay, and now I don't have a default value. Okay, and the result is nothing. Yeah, an empty string,
because it doesn't have anything. Cool.
Exactly. So now let's save. This is a secured value. Yep, that's it. I'm saving it. Now I'm coming, as we can see here on the stack trace. I got from here.
Get all the way back from there.
Exactly. Which are the arguments, as we said, it's the hash map with the key and value, and that's it. And then we didn't get to this exception, which is just being handled. I simply didn't put here the breakpoint. Okay, cool. So now let's kill the app here and run it on Android. And now that after we saved it, meanwhile, while the Gradle task is running, we can reactivate it, right? And see the value. This is a secured load, nothing, right? Because I need to put this is secured key. This is the actual key. Now I will load and crushing. Yay!
Hey guys, Dor and Perry from the future, coming to you after learning a valuable lesson about live coding and presenting.
Yeah, I forgot to test it before presenting it. I just copied paste the tool itself with its extensions and with not working methods, not the fully working. So let's explain what happened, and then we will continue with the previous video from Dor and Perry from the past So on that time, taking account that I didn't know what I know today, which is pretty simple, but on that time I didn't dive into it. So, oh yeah, I made a commit for that, so it will be very easy to explain. So basically, I'm dealing only with the strings. So this value method, okay, the value method that I'm using to convert from data to string and vice versa from string to data didn't work apparently. So these deleted the lines, okay? This actually only the saving part. The saving part went well, okay? I used some, where is it? Data from value, okay? I used this extension, which I blindly copied from the web. It uses unsafe pointer. It says unsafe, be careful, because it's unsafe. And it's used from some way to convert any data to, I guess, any type. Of course, it's redundant because I'm using only strings, and the string in Swift already has a constructor that gets a data and converts the data to string. So it failed here. This is the line that crashed the app. Okay, the data uses an extension that says 2, okay, and then it crashed because it uses this unsafe bytes. So yeah, I changed it to this one, to the plain old Swifty constructor of string that gets a data with encoding, and that's it. Problem fixed. The app won't crash now. To see the demonstration of the not fixing version, let's look at this one. Okay, I have the debugger. I'm debugging on Xcode, not on Android Studio, because I want to debug right now the native code. I'm debugging the Swift side. So let's use the same key. It was a secured key, I think. No, no, this is a secured key. Okay, and load. I think so. Okay, it stopped here. Right now, exactly, without crashing. Okay, and this is the line that actually crashed. And let's see the new constructor. We have the value. Okay, this is secured value. It's gonna put here from the native. It will be running through the method channel. We call it now native bridge. Through the native bridge back to Flutter, and there it is. That's it.
Right, let's get back to the show.
Yep. Yeah, I will see.
Let's see what happened.
Yeah. That's why I didn't say it's a live coding. Let's try here the same. Yeah. I will do exactly the same. This is a secured key. Load. I don't have anything. I shouldn't have anything. Great. The result is empty. And moving on. I will save. This is a secured value. Save. Now I'm actually pretty yeah, I think I'm gonna call my friend here, which is a Swift developer. He's gonna look on why is it crashing on the iOS side.
This is a good time to mention that the Flutter code does not crash. What it does is it pulls up this scary red, very alarming message that says you have a problem and you need to deal with this. But the app doesn't actually crash, which is amazing. If you do have a crash in a Flutter app, that means your native side crashed, and that's when you need to pull up with the big guns and try to go in and see what happens on the native side.
That's right. That's right. With time, we get used to this alarming red thing, and we even thankful for that because it's not crashing.
At the end of the day, this is what matters.
Yeah. So yeah, I saved it already. Now I will exit. No, let's kill it. Yeah. Goodbye. And I will rerun it. And meanwhile, I'll come back, I think, with the Swift developer form of myself.
See you soon.
Okay, yeah. So yeah, I called a friend of mine. She's a Swift developer.
Hey,
Hello.
I called a friend of
I
mine
got-
who's an Android developer now.
Oh, no, awesome.
Awesome.
Yeah, so we're gonna be native. Let's just finish a bit messed up, I'm sorry. But
Mhm.
let's say I just finished the demonstration of the Android, which I'm hoping it won't crash. This is a secured, right? Let's load. Nothing, should be nothing. Yep, nothing.
Mhm.
Secured, key. Loading, please don't crash. Great, yay, it didn't crash.
Amazing. And it got a
And
value.
yeah, so the Android works. Awesome.
Android always works. Said no developer. Now I'm kidding.
Yeah, okay. Okay, so we
Cool.
got native.
So let's dive into the native implementation, see what happens.
That's right. I just run it. It will run here on this iPhone 8.
So really what we wanted to do is look at two things. One, what does it mean for the app to be back on, both in iOS and Android, and how does the push, how does the push happen to the native bridge? And two, what the saving and loading looks like. And I think that's it.
The push, when you say push, is like the Flutter being presented. Is this one?
Yes.
This event
Yes.
you're talking about? Okay, cool. Yeah, exactly. So let's dive into the save and loading, because we just presented this one, and then we will show the other communication.
All of this implementation will be online, and all of this presentation will or code implementation will be uploaded. We're just focusing and narrowing into the most interesting part for this presentation only. With that said, all of this code is going to be available online for everyone, to see and look.
Right, exactly. The fixed code, the one that doesn't crash. Now let's see
the one that doesn't crash.
Yeah, I can debug it, and I can let's just let it crash. But let's try to put a breakpoint here. Here's the keychain save, keychain. I did save it, right? Let's see the received data. Maybe it's a casting error. Let's see what we got here. Cool, received data. Okay, so it didn't crash here. I did receive a data in bytes, and maybe it will crash here. Yep, exactly. That's exactly what happened. Eventually, it's crashing because of this translation from the secured data to the string, not because of the keychain. Okay, because I did receive a data for this key. Cool. So
it's just that it was the bunch of bytes and not necessarily like the thing.
Exactly.
We got a good opportunity to see what happens when the Flutter app crashes.
Right.
And how it would crash. Awesome.
Cool. If I'll make it in a short time, I can show the fix for it. So
cool. Meanwhile, let's take a look at the implementation. So let's take a look at the implementation. So for the save and load, let's go up a little bit.
All right.
We saw that we're using the keychain. So the keychain is the secured form of saving key value pairs in iOS.
Yeah, this is also a wrapper of the iOS actual keychain. Yeah.
I see. Okay, so this is your implementation of it.
Yeah, it's my wrapper for the iOS keychain.
Cool.
Okay.
Okay. And that stuff is just native stuff. Yeah, and this is just stuff that how to save it, where to save it, encoding, all of that stuff. Again, all of this will be uploaded and not to be dived into at the moment.
Right.
And how does and how does the Flutter? So this is the on Flutter call method, and I'm guessing the on Flutter call is your implementation.
Yes, and let's see, where did I put this on Flutter call? I gave the reference for the on Flutter call here. Here, when I use the Flutter view controller, the Flutter view controller actually has the whole Flutter engine embedded in itself.
So it kind of comes in. It kind of comes in all together in one package.
Exactly. So I simply used the Flutter view controller. Let's see. This is also, I think, my implementation. Maybe I used an extension for that. Let's see what happens here. I have this method called observe method channel. And yes, this is my implementation simply because I made an extension for the real Flutter view controller by Flutter. Okay. I added simply added a more explanatory.
Okay, I get it. So this is your extension function for the Flutter view controller that lets you do all of this fancy stuff. Okay, so what it lets you do is define the method channel, which has the same name I see as the one that we defined in the Flutter app in like the Dart code.
Right.
Cool.
Here.
And we're saying let's define that method channel, and we're using the binary messenger, which is
the same
Flutter's
binary
fancy way of.
Yeah, it's the same binary messenger that the same it belongs to this presenting view controller of Flutter. So that's
Cool.
why it works. Yes.
And then we're setting it.
Yeah, exactly. This new method channel, which uses itself a binary messenger, and then I'm putting here the closure for this handler. Eventually, it will all come to on Flutter call. Okay, which gets the Flutter call object by Flutter and the Flutter result callback by Flutter. That was implemented by Flutter.
Which was implemented before and returns the 1 and 0 that we saw earlier.
Yeah.
Awesome.
Here I'm gonna
and
call
I see that you have and I see that you also have a call Flutter method, which is the native
opposite
calls
direction.
Flutter direction.
Right, exactly. So if we go back
Where
just to this, that's why.
Okay.
Sorry, that's another extension, and this is the handler, the implementation of the handler itself. Yeah, I'm sorry.
And it's very similar to it's very similar, like a very similar API. You just go listen. Here's the callback. Here's the method. Here's the everything, and then your switch on the method that comes in.
Right. Here, yeah, exactly. Just use the fancy thing using emojis, etc. Just showing off the Swift code.
Swift and its emojis, emoji oriented programming.
Yeah, success result. I did something I would like to mention here that also in Android it works the same. I let the result string be an optional value, nullable value in Kotlin. Whenever this result string won't get any result, it won't be the result itself won't be called immediately, as you can see here. Okay, only if let the result string exists. It's like the let question mark, etc. So only if it exists, I will call immediately the result. Okay. The result, as a reminder, do you remember that we have this result type, Flutter result type, which is the callback that will come back to Flutter eventually. So I did it on purpose because if it's not exists yet, it will be in the responsibility of this handler, okay, of this case to call the result later. Maybe I'm doing a native, maybe I'm doing a native operation that also requires asynchronous operation. So I won't put here anything. It will be set to nil. If it's nil, I will have to use the result later. Otherwise, by the way, I can have a really bad issue where I'm using await, right, in Flutter, because we did platform.invoke method, and it's a future method, right? It's an async await method. So I can, by mistake, if I will forget to call this result, then on the Flutter side, it will await in how can I say it? It will
Indefinitely.
be waiting exactly indefinitely. Okay, forever. It will be waiting forever. Yeah, that's what I wanted to say. Okay.
Cool. And this is a debugging form.
Yeah.
Like this is your way of debugging. It's not like you want to make the code stuck. It's like it's your way to debug this thing and to make sure like the code actually works.
Yeah. I also mentioned it as a mistake that you can do by yourself. So if you see an await method that never comes back, so maybe the Flutter, so maybe the native side forgot to call the result.
Cool.
This also could happen.
So let's look at the native calling Flutter now, calling the bridge.
Okay, cool, no problem. I made also another method which called an extension method, which called call Flutter. It simply gets the method name, arguments, as we saw already in the Flutter side. I tried to use the same convention: method name, arguments if exists, and then a callback that I got from Flutter as the result, which will be 0 or 1. And then I'm using the same method channel. Wait 1 second. Okay, interesting. Somehow I'm creating a new one, which I don't like it, by the way. And note to self as well. Another note to self. I'm creating one instance, and here the same exactly the same instance, which are basically the same.
Interesting.
Right? Yeah, I didn't have to use this way. I would improve that just to do one creation. Only call the constructor of Flutter method channel only once and not multiple times, especially not every time I want to call Flutter, which is redundant. This observe, it's okay because it will happen only once. It will be still retained in the memory and it will wait for the Flutter call. But here on call Flutter, it's redundant. I would expose this to like I don't know, a place that can hold it. Maybe the app delegate. Yeah, we can improve that. So yeah, and then I'm calling the invoke method, which is the Flutter implementation of the invoke method, okay, which is implemented in Objective-C. Yeah, and I think that's it, right? Then I got here the
where do you call call Flutter in iOS?
Okay, yeah, let's see. I have it here. Okay, in these two events where we have this application did become active, which means the application is came back from background and also came back from dead, like a first run or another session, coming back to the coming back to foregone on the same session or a new session. Okay, that's the application did become active. And there's the application did enter background whenever the user presses the home button or another app is becoming in foreground, and then the other this Flutter app became entered the background.
So you have two. Okay, so there's two amazing callbacks. The application did become active. And application did enter background. And they use that in order to use the Flutter view controller to call the Flutter. And the Flutter view controller is you just save it to the side. It's something that's referenced in the.
Yeah, the reference is being saved on the side, but whenever you call a Flutter create and it created your iOS app, it will always have a Flutter view controller. I simply, yeah, I actually made it on myself just because I wanted to have a reference. There are other ways to get the reference. I personally chose to use my own instantiate method, which is simply takes
the
it from
UI
the storyboard.
one.
Yeah, it's
Cool.
another one of the many ways to create view controllers. But still, whenever you create your own Flutter app, you get this view controller, which is a Flutter view controller. Okay, so I
Awesome.
instantiated it from this storyboard. It's simply another way to do it. And then I have it, the reference to the Flutter view controller. Okay.
Cool. Very
Yeah.
cool.
Ah, cool.
So this
Man.
is
So I'm sorry for interrupting. I have another. I have an
yeah, no, go
improvement
ahead.
here. Okay, I have an improvement. As I said, that the app delegate can use this method channel. So yeah, I totally can use the same method channel instead of creating it here. Okay, I have this method channel, so I can call app delegate, shared, and method channel because I already have it here. Just so
Oh, you have a shared object in iOS. I did not
yeah,
know that. That's really cool.
yeah, it's shared. Yeah, it's another way. It's the iOS way to say how does it called? Get instance. It's the a singleton, and the app delegate is a singleton, just like application in Android is a singleton. Singleton.
Cool.
Yeah. So
Okay, awesome. So you don't really need to, so you can just use the one referenced in the app delegate and you're done. Awesome.
yeah, which was
Nice.
created here.
Very relatively simple, relatively not, not as bad as we thought. And we can do really, really amazing stuff with this. So that's the
Cool.
iOS
Cool.
side. Let's look at the Android side.
Right. Yep. Cool. So on Android, I also use, of course, Android Studio. Here you are, the Android side. So after we saw the iOS side, we can know what to expect on the Android side.
I'm guessing the Android implementation is going to be relatively similar. The things to look out for, the method channel name, the callback with the switch with all the method names that we need to look for, and where to invoke the native method, or invoke the Flutter method rather.
Exactly. So here's the same channel name. What else? This one is also, as I did the native bridge on Flutter. Here I also had the Flutter-Native bridge.swift. So here on Android, I also had a Flutter-Native bridge.kt of the Kotlin form of the same
So
object.
in this implementation, we're not extending the Flutter view controller like we're doing on Swift. Here, we're actually creating a class that extends the method call handler callback that we have. Cool.
Right. So here I have the repository. Why did I do that? I guess it has the secured. Yeah. Instead of using the keychain of iOS, I'm using here the shared preferences. It's not the regular shared preferences. It's this. I'm generating here a
Encrypted shared preferences.
Shared preferences. Yeah, exactly. Yes.
Cool.
Yeah, I know it's here. It's deprecated. Just I didn't want to spend the time on using the new form of this create method.
Yeah, but it essentially does the same
thing.
thing. It's a create method with the parameters all switched around, but it's essentially the same thing.
That's right. So here I have the save secured string. Okay, just here I decided only to save only strings. Of course, if it's your implementation and you want to make it more generic, go ahead, feel free to do so. So it's here, I'm saving the secured string. Let's see how am I getting here to this repository store. This is how I'm getting here on method call. Okay, let's see. Where am I calling the on method call? Only one place. I have the Flutter-Native bridge here. I created this method channel, right? As I did also in the app delegate of iOS. It's let's see, I'm creating it here with also with the binary messenger here and the channel name. Okay, so it's the same binary messenger that the whole app, the whole Flutter app uses, but I'm also giving it my own channel name, so it will know which method channel to send it the messages.
So you're giving it, so in the constructor, you're getting this thing, it's called a Flutter Bridge handler. And in the Flutter Bridge handler, it has a thing called a binary messenger, which is the same binary messenger we've been used to and saw in Dart, and we also saw in Swift, and now we're seeing it in Kotlin. And because this is a constructor, it happens every time this thing constructs. So unlike in the Swift implementation, this only happens once this object instantiates. So we have that method channel that's being created with the channel name. And then we set the method call handler to be an object that will just call on method call with a call, which is the thing that holds the method and the arguments, and the result, which is the call back to the Dart to say what the result of the method was.
Exactly, and then it comes back to the async await of Flutter. That's right.
That we saw previously. Okay.
Yeah, this one is I think the Flutter Bridge handler. No, I don't think. I know it's my implementation. I mean, it's only an interface for me to implement. Okay.
And who in the application class on their activity class implements it.
Exactly, because the main activity extends from Flutter activity, so I can easily get the binary messenger. It's from the Flutter engine because it's a Flutter activity. So the Flutter team already brought me, gave us this Flutter engine, Dart Constructor, and the binary messenger. Then I'm using it. And what was the other thing? Yeah, get context and get context, of course.
It's given.
Yeah, it's already given by every activity. Cool.
Awesome.
So,
cool. And call Flutter is very similar, like we saw previously. It's just here's the method. Do we have arguments? Do we have callback? Great. And it's the infamous let run. What's it called? The let run build, which is the Swift equivalent of if let. It's one of the very cool things. This is what happens when you let a Swift developer develop in Kotlin. They come up with this really cool stuff, and then you end up copying them. I use this in my work. I use this in my work all the time, and the Android developers that I work with, like it blew their minds when they saw this.
Oh, really? That's cool for it. So yeah, on method call. Yeah, I think we.
So again, we're using the same strings. This is the same stuff that happens.
Yeah.
It's just that we have the Android native implementation. We have the, if we scroll down a bit, we have the save in secured storage, which is the same string that we have in Dart. It's the same string that we have in Swift. And in this call, what we check is to make sure that we get a hash map, which is the object that we had in Dart that passes in the key and the value. And if we have it, great. We save it, and we send it back as a success result. Otherwise, we send back a failure result and log it. The same for the load secured storage.
Yeah.
And it's all native implementation. This is very familiar to native developers. If you're not a native developer, this is what native code looks like.
Yeah. And let's see quickly how am I handling it. Simply got a hash map of a key and value, one key and one value, calling the store. Yeah, we saw it before. And I'm using it as a really regular shared preferences. But on the behind the scenes, it's encrypted shared preferences. Cool. Let's see where am I calling the call Flutter. And I think we're done with the Android stuff. Here, simply on resume. Let's see. I have the call Flutter of the activity itself. Right now I'm in the main activity, which extends from the Flutter activity. I made here a call Flutter by its own, which simply wraps the call Flutter of the method handler. Sorry. Okay, which this is our
Now, something that I saw that's really cool. I'm not sure you intended to do this, but I just want to talk about this because it's really, really cool. You don't have to implement all the methods given. So unlike an interface where in an interface class, you have to implement all of the methods, in a native bridge, you don't have to implement all of the methods. It's advisable to do that, but you don't have to. In this case, in this implementation, we didn't implement the Flutter is background, or Flutter is when the Flutter is going down. In this implementation, all we did is just do on resume. It could be because we forgot. It could be because it wasn't intentional. But there are some cases in which, you know, Android can do stuff and iOS cannot, and vice versa. iOS can do stuff and Android cannot. So in this scenario, in this example specifically, we didn't do the on pause. Maybe it's something we'll add later. Maybe we'll, you know, give a comment on this in the final code just to be like, this is something you can do.
Totally. It's by mistake.
But for now, we'll add it to do.
But it was, for now we will add it to do. And Flutter was, I don't know, disappeared or something, appeared.
whatever the method was.
Exactly.
The example I had with a native component, I had an example and then I forgot what it was. Edit that out.
Okay.
There are some implementations of things that happen on iOS and do not on Android, and vice versa. It just is a fact of life, and you have to learn how to deal with it as a Dart developer because you serve everyone, and it's great.
Right. Even web, macOS, Windows. Yeah.
Oh yeah, we haven't even talked about that. Can the native bridge? Can you use the native bridge to talk with the web OS and other OSs?
I can tell you for sure because that's what I'm doing on work. On my day-to-day job, I'm using the Mac OS, and yes, it works perfect. It helps me a lot, this native bridge. So I'm pretty sure it will work also on the web. I don't know for sure. I never tried it yet, so I cannot tell you for sure if we have a native bridge for web. But yeah, for Mac OS and Windows, I'm sure it's also available. Yeah.
This also means, you know, for TVs and things like cars, you know, if you're into that development stuff, right? So if you're into that stuff, this can happen
heading
too.
There.
And that's heading there.
And that's where we're heading, right? Awesome. I think we covered pretty much everything. Correct me if I'm mistaken.
Yeah. This is a really, really cool topic, and it can get very complex very quickly. So we did our best to do, you know, the most condensed version of the native bridge, and even that took us an hour, I think, to talk about, if not even more.
Right.
With that said, it's been a pleasure to talk to, and it's been a pleasure to go through your code. So thank you for letting me look at it and taking a crack at it.
It's always a pleasure for me too.
And thank you all for tuning in and listening to our very late night conversation. It is 12:03 at the moment, and we haven't had hummus in a while. So Perry, you know, get on that.
To do.
Cool. So thank you. So to do, yeah, exactly. So thank you everyone, and thank you for joining us. And please ping us on any social media that will be presented on the screen at the moment. And please ask us any questions that you have at the moment, and the updated code will be uploaded to a link attached to this video.
Awesome. Thank you very much, Dor Summit, for your time for this late hour. And of course, I'm always enjoy it. Thanks, man. See you guys.
Bye, everyone.